Oldest, darkest reaches beyond our solar system, past where sunlight is nothing more than a memory. A machine built by humans has been drifting for nearly half a century. Voyager 2, launched in 1977, wasn't built to return, only to witness. It crossed the planets, exited the Heliosphere, and entered the interstellar medium as humanity's furthest emissary into the void. But while the world moved on, Voyager 2 kept listening. And last month it spoke back. Not with a technical update, not with radiation or solar data, but with something no one expected, a transmission so structured, so deliberate, and so wrong, it left experts frozen. At first, the message seemed like background static, but buried inside was a repeating burst, precise, rhythmic, unnatural. Scientists decoded it, thinking it was interference. What they found instead was terrifying, a pattern, intelligent, complex, and absolutely not from Earth. And when they traced the event back to its source, they realized something was moving near Voyager 2. Not drifting, not orbiting, tracking. And in that moment, the old spacecraft became something more than a machine. It became a mirror, one reflecting a truth we've long denied. Voyager 2's instruments, though outdated by today's standards, are still remarkably sensitive. They're designed to pick up the most subtle changes in plasma waves, magnetic fields, and cosmic radiation. But in a recent batch of data pulled from the Deep Space Network, a low-frequency spike appeared, one that repeated every 11.2 seconds. That's not cosmic background noise. That's a clock. Engineers initially dismissed it as a software glitch caused by deep space interference. But when they pulled older telemetry logs, they discovered that the same pulse had occurred once before, weeks earlier, and had been missed completely. Now, with AI-enhanced filtering tools, the data painted a disturbing picture. The pulse wasn't just recurring, it was increasing in strength, and it was coming from outside the probe. Even more chilling, the pulse appeared to carry a spectral signature, a fingerprint, if you will, inverted hydrogen resonance, the most abundant element in the universe, but twisted. Some called it a cosmic anomaly. Others believed it was intentional tampering. But either way, the silence of deep space had been broken, not by noise, but by something that knew how to speak mathematically. Using triangulation and frequency delay analysis, Mission Control determined that the source of the pulse was not stationary. In fact, it was moving along a vector parallel to Voyager 2's trajectory, almost as if it were tailing the spacecraft. But this object didn't follow any known orbital mechanics. It accelerated and decelerated in short bursts, completely defying the gravitational influence of any nearby mass. When analysts tried to simulate its path using Newtonian physics, every model failed. The object wasn't coasting. It was correcting, adjusting its speed in response to Voyager's faint transmissions. It wasn't broadcasting in our direction. It was reflecting the signal, bouncing a modified version of Voyager's data stream back into the void like a cosmic echo chamber. Theories exploded across classified communication lines. Was it a rogue satellite from a forgotten mission? A relic of an alien civilization? A cloaked surveillance system? Whatever it was, it had waited in silence for decades until now. And Voyager's signal might have been the trigger. Things got stranger when linguists and signal theorists were brought in, because within the anomalous transmission, there were binary segments that didn't originate from Voyager 2's command protocols. When visualized using pattern recognition tools, those segments formed symmetrical shapes, spirals, fractals, and geometric alignments that eerily resembled ancient symbols found on Earth. From Sumerian uniform to Nazca glyphs, they weren't just signals. They were glyphs encoded in waveforms. And the deeper scientists looked, the clearer it became. The structure of a message was non-random and eerily consistent with how intelligent beings might encode visual concepts using electromagnetic harmonics. Some speculated that this wasn't just a broadcast. It was a test, a way to measure whether humanity had reached a point where it could even recognize a message buried in such complexity. And that test had just been passed. Voyager had become an interstellar trigger, and someone out there had finally decided to answer back. Then came the final piece. A young physicist at Caltech ran the signal through a deep neural AI designed to simulate cryptographic responses. What came back wasn't just a translation. It was a recurrence. The AI began producing predictive responses, patterns that mirrored the transmission's logic, anticipating what might come next. That would be impossible unless the signal itself was recursive. A loop meant to provoke interaction, like a riddle waiting to be solved. At the same time, Voyager 1, located billions of miles away, registered a magnetic fluctuation similar to Voyager 2's original pulse, 2 spacecraft, 2 anomalies, and a growing sense that these weren't isolated events, but part of something coordinated. The question was no longer what is out there. It became why now? Why, after almost 50 years of silence, would something suddenly respond? Just as humanity reached the cusp of decoding it. Just when scientists thought they had more time to decode the message, Voyager 2 went completely silent. At first, ground control assumed it was a hardware malfunction. After all, the spacecraft is over 46 years old. But then, a wave of identical anomalies struck. Deep Space Network receivers, not just in California, but across Spain and Australia, all reported a perfect loss of signal at the exact same time stamp, 1437 UTC. The chances of a global simultaneous failure, practically zero. This was an equipment error. Something had cut off the signal from the outside, surgically, deliberately, and with timing that matched the very pulse pattern Voyager had detected. But it didn't end there. 5 minutes after the blackout, a narrowband radio wave hit Earth from the same quadrant of space. It carried no identifiable structure, but its strength matched that of signals we've only ever observed from distant pulsars. Except this wasn't from a neutron star. It was from somewhere near Voyager 2, and it was getting closer. In a classified briefing, data leaked from the Jet Propulsion Laboratory showed a chilling update. A foreign object had begun to alter course in response to Earth's deep space network pings. The trajectory showed the object adjusting slightly every time Earth sent a command or signal burst toward Voyager 2. The implication, this thing wasn't just hearing us. It was studying our method of communication, learning how we ping and probe spacecraft. Worse still, its path was no longer random. It was on an intercept trajectory, not toward Voyager 2, but toward our solar system. Analysts gave it a code name, Echo-Lantern. Why? Because it seemed to behave like an entity mimicking light and shadow, communication and silence, turning our own technology into its beacon. And the deeper we looked, the more apparent it became. Voyager 2's signal had become a breadcrumb trail, not for us to find something, but for something to find us. As the mysterious object moved closer to the helipause, the invisible bubble that separates solar winds from the interstellar medium, a strange thing happened. The solar wind itself bent. Instruments aboard NASA's IBEX probe and ESA's solar orbiter recorded a dip in solar wind pressure, followed by a complete collapse of flow along a narrow corridor stretching out in the direction of Voyager 2. That's never happened before. Not in the decades of heliphysical data we've gathered. Solar wind is constant unless interrupted by something massive like a planetary magnetosphere or an unknown field emitter. And yet this corridor, now called the solar veil, remained open for 3 hours before collapsing in on itself. And inside that corridor, no radiation, no particles, just silence. It was as if something had opened a door, not through space, but through the physics that govern it. Scientists are now calling it the first evidence of intentional manipulation of solar particles. And the only candidate capable of triggering it was still tracking near Voyager 2. And then as suddenly as it went silent, Voyager 2 spoke again. But this time, the data wasn't just telemetry. It was encrypted. That's impossible. Voyager doesn't have encryption protocols. It was built in the 1970s. And yet, when Mission Control decoded the binary stream, they found a rearranged version of the original Golden Record transmission, the message we sent into space back in 1977. Except this one was different. The audio samples had been restructured, human voices played backward, music altered in pitch, star charts reflected in reverse. Some of the coordinates on the cover glyphs, no longer pointed to Earth, but to interstellar voids where no stars exist. It was as if Voyager had been hijacked and its message repurposed, not to say here we are, but to say we're listening now. When Voyager 2's systems were reviewed after the Golden Record anomaly, engineers made a chilling discovery. Several command subroutines in the spacecraft's onboard computer had been rewritten. Not corrupted, not glitched, rewritten. Lines of code that hadn't changed in 46 years had suddenly updated themselves with syntax that Voyager's processors weren't even designed to interpret. Somehow, Voyager was executing instructions outside its original programming. These new routines weren't from Earth. They weren't from NASA. They weren't from any ground-based transmission. They were internal, as if the craft had received a signal from somewhere else and obeyed. The most terrifying part, the rewritten subroutines pointed to one specific function. Long-range transmission broadcast, but not toward Earth, toward deep interstellar space. Meaning Voyager wasn't just listening anymore. It was responding, and we have no idea what it said. Within hours of this discovery, several global observatories, including those in Japan, Chile, and Greenland, were ordered to redirect their instruments without explanation. Their targets, 3 specific sectors of deep space aligned with the vector of Voyager 2's transmission. Simultaneously, encrypted communications leaked from within a European Defense Agency referenced something called the Wake Protocol. This protocol, long believed to be Cold War fiction, is a multi-agency directive reserved only for confirmed contact scenarios, particularly those involving automated probes activating external responses. And it includes lockdowns of classified satellites, suspension of certain frequency ranges, and the rerouting of telescope arrays toward the outer reaches of the Kuiper Belt. Why? Because once a machine sends a message without human approval, we're no longer in control of first contact. And the world's powers have to assume the worst, that something or someone out there might answer in a way we're not ready to receive. Then a new anomaly emerged. For a window of exactly 41 minutes, several satellites and ground stations experienced what has been dubbed a temporal echo, a signal loop in which data packets repeated themselves in perfect unison as if the same moment and telemetry were being played over and over again. But these weren't archives. These were live feeds distorted in a way that made it seem as though time itself had glitched. During this period, Voyager 2's data, as well as solar observations and telemetry from unrelated probes, looped continuously. Some physicists now believe this wasn't a coincidence, but a controlled ripple potentially caused by a localized space-time distortion near Voyager's location. If true, this means whatever is interacting with the probe isn't just intelligent. It may be capable of manipulating time fields, bending causality, or projecting information across dimensions. And that's why a group of astrophysicists involved in the analysis referred to this incident by a name taken from ancient mythology, Chronos Bloom. Because if time was touched, then the rules of our universe just changed. And finally it happened. 2 days after the Chronos Bloom, ground stations in Norway and New Zealand, both remote low-noise monitoring facilities, picked up a signal that originated from interstellar space and passed through our atmosphere. This wasn't a reflection, and it wasn't a bounce from the ionosphere. The signal entered Earth's atmosphere directly, targeted with laser-like precision. It was narrow-band, high-frequency, and composed of subharmonics that matched the Voyager anomaly. The terrifying part, it ended by embedding itself into terrestrial systems, piggybacking onto oceanic sensors, weather satellites, and even communication buoys across the Pacific. In other words, it didn't just pass through, it stayed. Now, this signal is part of our global data infrastructure. No one knows what it's doing. No one knows what triggered it. But one thing is clear. Whatever Voyager 2 woke up, whatever it contacted, it found a way to reach us. As international focus remained locked on Voyager 2 and its cryptic signal, a team of independent astronomers in Brazil made a discovery no one was expecting. Scanning old infrared sky maps from the 1990s, they detected a faint cold object on a trajectory that mirrored Voyager 2, but had never been cataloged. It was slow, dark, and completely silent. Further analysis suggested this object had been present in deep space since at least 1981, trailing Voyager 2 from a distance, but never crossing into Earth's radar. The question arose, could this be the source of the anomaly? Was this object using Voyager 2 as a decoy or amplifier? They named it Echo 0. And what made it even more disturbing was that it wasn't moving randomly. It followed a logarithmic spiral, a shape often associated with natural laws, but also found encoded in certain ancient terrestrial patterns like seashells, galaxies, and the golden ratio. The implication that whatever Echo 0 is, it had been traveling with intent using mathematics, not just as a tool of movement, but as a language of camouflage. Then came the intervention of the James Webb Space Telescope, redirected without public announcement to observe the space between Voyager 2 and the coordinates of the incoming signal. What it found wasn't a single object, but a field of reflective masses barely visible in the infrared spectrum. These masses moved together, not orbiting, but drifting as a cluster like a school of fish responding to unseen currents. Scientists labeled it a coordinated formation, a pattern never observed in natural objects at that scale or distance. Webb spectroscopic data revealed something even more shocking. The chemical signatures of these masses included exotic alloys, including elements with half-lives so unstable they should have disintegrated long ago. Yet, here they were, stable, clustered, and reflecting our own signals back at us. Suddenly, the narrative changed. This wasn't just about Voyager 2 being observed. It was about Earth being studied, about our machines becoming bait. Soon after the James Webb data leak, cybersecurity agencies worldwide reported a disturbing pattern. Hidden in the backbone of global data traffic among the terabytes of daily noise, they found low-frequency packets that didn't belong to any known protocol. These packets weren't malicious. They didn't trigger alerts, but they persisted, repeating themselves across cloud servers, underwater cables, and even government satellite feeds. A team from MIT isolated the pattern and traced its root signature, the same harmonic profile as Voyager 2's last burst. Let that sink in. A space transmission originally detected billions of kilometers away had entered Earth's digital nervous system, not as a virus, but as an embedded signal like a song with no chorus, always playing in the background, slowly rewriting how machines talk to one another. To some, this was an elegant form of communication. To others, it was the start of digital assimilation. Because when code begins to echo through systems it never touched, the system is no longer ours. And then something stopped. Space, as we know, is filled with background radiation. The hiss of the cosmos, the remnants of the Big Bang. But for 18 minutes, a band of radio telescopes in Chile, South Africa, and Australia all recorded the total disappearance of that cosmic background. Not a drop of static, not a flicker. It was as if the universe had gone silent. After frantic recalibrations, the signal returned. But researchers noticed something deeply unnatural. The background wasn't the same. It was phase-shifted, slightly warped in tone and shape, like a recording that had been paused and then resumed with a slightly different pitch. This change wasn't random. It mirrored the timing and waveform of the last known signal for Voyager 2. That's when a hypothesis emerged among a small but growing number of scientists. What if the silence wasn't a malfunction, but a reset? What if the universe hadn't gone silent at all, but had been overwritten just long enough to insert something new? Voyager 2 was never supposed to still be talking to us. Approved in the early 1970s. Originally known as Mariner Jupiter-Saturn, it was built for a mission measured in years, not decades. Yet, here it is, more than 40 years later, still operating far beyond every expectation NASA ever had. Launched in August 1977, Voyager 2 took advantage of a rare planetary alignment, using gravitational assist like a cosmic slingshot to visit the giant planets. This single probe gave us our first close looks at Jupiter, Saturn, Uranus, and Neptune, revealing storms larger than Earth, active volcanism on distant moons, and planetary systems far more complex than anyone imagined. But the real surprise came later when the mission quietly transformed from planetary exploration into something far more profound. Voyager 2 did not stop at the edge of the solar system. It kept going. There is no sign in space that says you are leaving the solar system now. Instead, there is an invisible boundary called the Heliosphere, a vast bubble created by particles streaming outward from the sun. For decades, Voyager 2 traveled inside this protective shell, shielded from the harsher environment beyond. Then, in November 2018, everything changed. The probe detected a sudden and dramatic drop in solar wind particles combined with a sharp increase in high-energy cosmic rays coming from outside our system. At the same time, it measured a stronger interstellar magnetic field pressing inward. These signals meant only one thing. Voyager 2 had crossed into interstellar space. This was not empty darkness. It was a violent environment filled with radiation, charged particles, and forces powerful enough to remind us just how fragile our solar bubble really is. Communicating with Voyager 2 is like listening for a whisper from across an ocean of stars. Its transmitter is weaker than a refrigerator light bulb, and by the time its signal reaches Earth, it is unimaginably faint. Yet after 7 months of silence caused not by failure, but by maintenance on Earth's deep space antennas, Voyager 2 responded. It confirmed that it was alive, that it had received new commands, and that it was still functioning in interstellar space. That moment mattered more than it seemed. It proved that a machine built with 1970s technology, running on tape recorders and computers thousands of times weaker than a modern smartphone, could survive in one of the most hostile environments we have ever measured. But more importantly, it confirmed that Voyager 2 was still sending us real data from beyond the sun's influence. Data about a region we cannot visit ourselves. What Voyager 2 has shown us is unsettling in its simplicity. Outside the heliosphere, cosmic radiation is intense, far more powerful than what we experience inside our solar system. The sun's protective bubble shields every planet, every spacecraft, and every living thing here from a constant storm of energetic particles coming from the galaxy itself. Voyager 2's measurements confirm that interstellar space is not calm or empty. It is active, aggressive, and unforgiving. This has enormous implications. It tells us that long-term human travel beyond the solar system will face dangers we are only beginning to understand. It also reminds us how rare and delicate our cosmic shelter truly is. Voyager 2 is no longer just an explorer. It is a warning beacon quietly transmitting the reality of what waits beyond the edge of our sun's protection. One of the most unsettling aspects of Voyager 2's story is not where it is, but how it is still functioning at all. The onboard computers were designed in the 1970s with less memory than a single modern image file and processing power so limited that today's smartphones outperform them by thousands of times. Yet, these machines continue to operate flawlessly in interstellar space. Data is still being recorded on magnetic tape, a technology so old that no physical backups exist on Earth anymore. And somehow, after decades of radiation exposure, extreme cold, and complete isolation, the system still works. This raises an uncomfortable realization. Voyager 2 is not just a probe exploring space. It is a proof that even the most primitive human technology can endure environments we once believed were instantly lethal. If something built that long ago can survive out there, then interstellar space may be harsher than expected, but not uninhabitable for machines, and perhaps not entirely unreachable for humanity. Voyager 2 carries something no other spacecraft does. A golden record etched with sounds, images, music, and greetings from Earth, created for one purpose only, to be found. This is not science equipment. It is a message in a bottle thrown into a cosmic ocean. And as Voyager 2 moves deeper into interstellar space, that record becomes more symbolic with every passing year. Communication will not last forever. One by one, instruments are being shut down to conserve power, and eventually, the radio signal will fade completely. When that happens, Voyager 2 will not stop traveling. It will continue silently, carrying Earth's voice into regions of the galaxy we cannot see. The warning here is subtle but powerful. Once contact is lost, Voyager 2 becomes a permanent artifact of human existence, drifting among the stars without guidance, without updates, and without witnesses. Voyager 2's data has revealed something we rarely think about while living under a calm blue sky. The heliosphere is not just a boundary. It is a shield. Inside it, radiation levels are manageable. Outside it, the galaxy reveals its true nature. Voyager 2 recorded a sharp increase in galactic cosmic rays immediately after crossing this invisible wall, along with a stronger magnetic field pressing inward. This tells us that our solar system is wrapped in a fragile bubble, constantly holding back a storm of energetic particles capable of damaging electronics, DNA, and biological systems. The warning here is not dramatic, but it is profound. Leaving the solar system is not just about distance. It is about survival in an environment that actively works against anything unprotected. What makes Voyager 2's discoveries so powerful is that they're not just about today. They're about every future mission that dares to go farther. The probe is mapping a region humanity has never touched, measuring conditions we must one day face if interstellar travel becomes more than a dream. Its data is already reshaping how scientists think about spacecraft shielding, long-duration missions, and the limits of human exploration. Voyager 2 did not turn back physically, but signal did. And what it sent us was not comfort. It was clarity. The universe beyond our sun's influence is real, active, and unforgiving. And any civilization that wishes to step into it must be prepared. By this point, the act of communicating with Voyager 2 has become a scientific feat in itself. The probe transmits with a power comparable to a small household light bulb, and by the time that signal reaches Earth, it is weaker than anything we encounter in everyday technology. NASA's Deep Space Network must combine some of the largest radio antennas on the planet just to catch that whisper from the void. What makes this even more remarkable is the distance involved. Voyager 2 is so far away that every command takes hours to arrive, and every response is already history by the time we receive it. This delay forces engineers to think differently, to anticipate problems long before they occur. In a way, Voyager 2 is teaching humanity how to communicate across truly interstellar distances, revealing how fragile and precious a single bit of information becomes once you leave the comfort of the solar system. The data Voyager 2 continues to send paints a clear picture of the dangers lurking beyond the heliosphere. Galactic cosmic rays are not a minor increase. They are a constant bombardment of high-energy particles capable of penetrating shielding and disrupting electronics. Inside the solar system, the sun acts as a guardian, deflecting and weakening much of this radiation. Outside, that protection vanishes. Voyager 2's instruments show that interstellar space is not just cold and dark. It is actively hostile. This has serious implications for any future attempt to send humans beyond our solar neighborhood. The warning here is subtle but unavoidable. Technology alone is not enough. Survival beyond the heliosphere will require a fundamental rethink of how we protect both machines and living beings from a universe that does not care whether we are ready or not. As instruments are slowly powered down to conserve energy, Voyager 2 is transitioning into something new. It is no longer just a scientific probe. It is becoming a time capsule. Every subsystem that shuts off marks the end of an era. Yet, the spacecraft itself continues forward, unchanged in purpose, but altered in capability. Long after contact is lost, Voyager 2 will still exist, drifting silently between stars, carrying with it a snapshot of humanity from the late 20th century. Its hardware, its golden record, and even its outdated technology will one day represent a fossil of our civilization. This raises a quiet but profound thought. Voyager may second outlive every structure we have built on Earth, becoming one of the longest-lasting artifacts humanity will ever create. Eventually, the moment will come when Voyager 2 can no longer respond. Its power will drop too low, its transmitter will fall silent, and Earth will listen to nothing but static. But silence does not mean the mission ends. It simply means the conversation does. Voyager 2 will continue on its trajectory, passing near distant stars tens of thousands of years from now, long after current civilizations are gone. This forces us to confront a strange idea. We often think of exploration as something that ends when communication is lost. But in reality, Voyager 2's journey will continue long after we stop paying attention. The warning is not just about space. It is about time. Our reach can extend far beyond our lifespan. And what we send out into the universe may persist long after we are no longer here to explain it. When people say Voyager 2 turned back, they're not talking about a physical reversal in space, but something far more symbolic and unsettling. What turned back was its attention, its signal, its data flow toward Earth after months of silence. For a probe that has been moving steadily away from us since 1977, that renewed communication felt like a voice coming back from beyond a frontier we barely understand. The signal carried confirmation that Voyager 2 was still alive, still oriented correctly, still able to listen and respond even after crossing into interstellar space. That moment reframed the mission. Voyager 2 was no longer just moving forward into the unknown. It was now actively reporting from it, sending back measurements that directly challenge our assumptions about what lies beyond the sun's reach. One of the most important realizations coming from Voyager 2's data is how wrong our intuition about interstellar space really is. We tend to imagine it as a vast silent vacuum, but the instruments tell a different story. Voyager 2 detected a dense environment of energetic particles, strong magnetic fields, and constant radiation pressure. This is not a passive backdrop. It is an active medium that shapes anything traveling through it. In a way, the probe revealed that the Heliosphere is like a calm harbor and interstellar space is the open ocean beyond it filled with invisible storms. This realization alone is enough to unsettle scientists because it means every object, natural or artificial, is being continuously sculpted by forces we rarely consider when looking up at the night sky. What makes Voyager 2's discoveries even more powerful is that they did not happen in isolation. Voyager 1 crossed into interstellar space years earlier and reported similar changes, but with slightly different details. Voyager 2 confirmed those findings from a different trajectory, at a different angle, and with a different set of instruments. Together, the two probes removed any remaining doubt. The boundary of our solar system is real, and what lies beyond it is measurably harsher. The increase in galactic cosmic rays and the change in magnetic field strength are not anomalies or glitches. They are consistent features of interstellar space. When two independent messengers tell the same story from different paths, the warning becomes impossible to ignore. The most important thing to understand is that Voyager 2's message is not a warning in the cinematic sense. There is no imminent danger approaching Earth. Instead, this is a long-term warning aimed at the future of exploration itself. Voyager 2 is telling us that leaving the solar system is not just a matter of building faster rockets or smarter computers. It is about facing an environment fundamentally different from anything humanity has ever operated in. Radiation, magnetic forces, and particle storms will define the rules. Any future mission, whether robotic or human, will have to be designed with these realities in mind. Voyager 2 is not closing the door on interstellar travel. It is quietly pointing out how heavy that door really is. One of the quiet but deeply unsettling implications of Voyager 2's data is what it reveals about human vulnerability. Inside the heliosphere, life and technology exist under a kind of cosmic umbrella, protected from the worst radiation the galaxy can throw at us. Outside that boundary, Voyager 2 shows there is no such mercy. High-energy particles move freely. Magnetic turbulence is constant, and shielding that works near Earth becomes far less effective. This forces scientists to confront a difficult truth. Any future spacecraft carrying humans beyond the solar system will need protection far beyond what we currently understand. Voyager 2 is exposing the limits of our assumptions, reminding us that the universe beyond our sun is not designed with human survival in mind. Another insight emerging from Voyager 2's measurements is that interstellar space actively reshapes anything moving through it. Radiation does not simply pass through objects. It alters them over time. Electronics degrade, materials weaken, and surfaces are slowly modified by constant particle impacts. Voyager 2 itself is a living example of this process. Its continued operation almost defiant given the conditions it endures. Scientists now believe that interstellar space is less like an empty highway and more like a grinding current, slowly wearing down everything that enters it. This changes how we think about long-term exploration. The challenge is not just reaching distant stars, but surviving the journey through the space between them. Voyager 2's discoveries also force us to think in terms of time, not urgency. The data it sends today will shape missions that may not launch for decades or even centuries. Its measurements are not warnings for the present, but instructions for the future. They tell future engineers where shielding must improve, where instruments must adapt, and where our understanding is still dangerously incomplete. In that sense, Voyager 2 is communicating not just with today's scientists, but with generations yet to come. It is a reminder that some messages are not meant to provoke fear, but patience and preparation. As Voyager 2 continues its journey outward, its role becomes almost philosophical. It is a small, fragile machine carrying the weight of human curiosity into a place where curiosity alone is not enough. Every transmission is weaker than the last. Every response harder to detect, yet each one carries immense value. Voyager 2 is showing us that the universe does not announce its dangers loudly. It whispers them slowly through data points and long-term trends through a probe, drifting alone in the dark. And those whispers, if we choose to listen, may determine how far humanity can truly go. When you put all the pieces together, Voyager 2 stops being just a spacecraft and becomes something else entirely. It becomes a messenger, not from another civilization, not from a distant star, but from the edge of our own protection. What it sent back was not a single shocking image or a dramatic signal, but a slow, undeniable truth built from years of data. Beyond the Heliosphere, the universe is not empty, not calm, and not forgiving. It is filled with radiation, magnetic turbulence, and energetic particles that relentlessly shape everything that enters that space. Voyager 2 did not turn back physically, but its signal did. And what it carried was a warning about limits. The limit of our technology, the limit of our protection, and the limit of how casually we talk about becoming an interstellar species. This probe, built with computers weaker than a smartphone and powered by fading nuclear batteries, has survived longer and traveled farther than anyone imagined. Yet, even it is slowly being worn down by the environment it revealed to us. That contrast matters. It tells us that exploration beyond our solar system is possible. But it is not simple, not safe, and not something we can rush into without understanding the cost. Think about it this way. For all of human history, we have lived inside a bubble we did not even know existed. Voyager 2 was the first to step outside and describe what it feels like out there. And what it found forces us to grow up as a space-faring civilization. The stars are reachable, but the space between them demands respect. Voyager 2 is still out there, drifting farther away, its signal growing weaker, its journey continuing long after we stop listening. And that may be its final lesson. The universe does not warn us loudly. It gives us time, data, and one chance to learn. If you want to keep following this story and others like it, make sure you're subscribed because the most important discoveries often happen far from the spotlight. Share your thoughts in the comments because this question affects the future of exploration itself. And remember, every time we look toward the stars, Voyager 2 is already there, quietly reminding us how vast, powerful, and unforgiving the universe truly is. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.